There is a number buried in a government report that predicts the end of one of America's oldest cities. It forecasts 900 dead, over 44,000 injured, and a single day of destruction costing $20 billion. The city is Charleston, South Carolina. And the prediction isn't for a storm or a flood. It is for an earthquake, a repeat of a catastrophe that struck in 1886, caused by a fault line that no one can see, buried deep beneath the coastal plain. For more than a century, that fault has been mostly silent, a ghost in the geology. And now, the ground in South Carolina is shaking again, not just once or twice. In 2024, the state recorded 30 separate earthquakes. In 2025, that number rose to 35. As of this summer, halfway through 2026, the count is already at 27. The historical average for a whole year is 10. On February 26, 2026, a magnitude 3.0 quake rattled homes near Lake Murray, sharp enough that the state geologist Dr. Scott Howard thought it was a delivery truck rumbling down his road. On June 28th and 29th, 2 more quakes hit in 48 hours. The state is experiencing a seismic awakening on a scale no one alive has ever witnessed. A long, sustained swarm of tremors that will not stop. The immediate conclusion is terrifying. The fault that nearly erased Charleston in 1886 has woken up. But here's what the initial data doesn't tell you. These new swarms, the ones shaking houses in towns like Elgin and Lugoff, are happening over 100 miles away from Charleston. They are not coming from the 1886 fault. They are coming from something else entirely. A different system, waking up for different reasons. And that makes the problem infinitely more complex. So the real question is, what is happening under the soil of South Carolina? A state thought to be stable, quiet, and safe. Did the ghost of 1886 just send a warning shot from 100 miles away, or has a second, entirely new threat just emerged from the ground? Charleston was never supposed to break. On the evening of August 31st, 1886, the city was settling into a warm, humid night. Gas lamps flickered to life. Families sat on their porches. At approximately 9:50 p.m., a low, distant roar began, a sound that witnesses would later describe as 1,000 freight trains approaching from all directions at once. The ground began to vibrate. Then it began to heave. For nearly a full minute, the earth beneath Charleston did not just shake. It violently liquefied. The city was built on a foundation of sand and coastal sediment, and in that minute, the ground lost all integrity. Fissures ripped open in the streets. Geysers of sand and water erupted from the earth, shooting into the air and leaving behind craters 20 feet wide. These were not aftershocks. They were the ground itself, coming apart. Buildings constructed from brick, the city's signature architectural feature, stood no chance. Walls collapsed inward. Entire facades peeled away and crashed into the streets. 2,000 buildings were severely damaged. Fires broke out almost immediately as gas lines ruptured, and with water mains also broken, firefighters could only watch as the flames consumed what the shaking had not already destroyed. It was a magnitude estimated between 6.9 and 7.3. The deadliest earthquake ever recorded on the east coast of the United States. When the final accounting was done, at least 60 people were dead. The financial toll reached $6 million, an astonishing sum for the time, equivalent to nearly $200 million today. But the psychological impact was immeasurable. The shaking was so profound, so utterly alien to the East Coast, that it was felt across 2.5 million square miles. People felt the tremor in Boston, in Chicago, in New Orleans. Reports even came from as far away as Cuba and Bermuda. In the days before instant communication, wild rumors spread across telegraph wires. One of the most persistent was that the entire peninsula of Florida had cracked off the continent and sunk into the Atlantic. That is what it felt like. A moment when the continent itself seemed to be breaking. And the most terrifying part was that nobody knew why. An earthquake like this was supposed to happen in California. It was supposed to happen along the San Andreas Fault, a visible, tangible scar in the earth where 2 tectonic plates grind against each other. It was not supposed to happen here. The American East Coast sits squarely in the middle of the North American plate. It is an intraplate zone, geologically stable, ancient, and quiet. There are no major plate boundaries for thousands of miles. The catastrophe of 1886 was by every known geological rule impossible, and yet it had happened. For decades, the cause remained a mystery. It wasn't until the 1970s that a clearer picture began to emerge, spearheaded by Dr. Pradeep Talwani, a geophysicist at the University of South Carolina. In 1974, Talwani founded the South Carolina Seismic Network, a web of sensors designed to listen to the state's deep, imperceptible tremors. What his work eventually uncovered was an enemy that operated in complete secrecy. Buried thousands of feet beneath the soft coastal sediment, hidden from any satellite or surface scan, lie two ancient, intersecting faults. The first is the Woodstock Fault, a deep, right lateral strike-slip structure trending northeast. It's an old wound in the planet's crust, left over from the breakup of Pangaea hundreds of millions of years ago. Crossing it is the Ashley River Fault, a shallower reverse motion fault. Together, they form the Middleton Place-Summerville Seismic Zone, or IMPS, a nexus of geologic stress located just 20 kilometers northwest of Charleston, directly under the town of Summerville. The 1886 epicenter. This wasn't a plate boundary. It was an old, forgotten weakness in the middle of a plate, being slowly compressed. The engine of this pressure is the Mid-Atlantic Ridge, an undersea mountain range where new crust is born, pushing the North American plate westward at a rate of about 1 inch per year. That infinitesimal push, compounded over millions of years, builds up stress in the continent's hidden weaknesses. Most of the rock absorbs it. But sometimes, an old fault, locked for centuries, can't hold the strain any longer. It slips. And when it slips in the eastern United States, the effect is disproportionately violent. The rock of the East Coast is different. It is older, colder, denser, and more rigid than the fractured, younger rock out west. California's geology is like a pile of rubble. It absorbs seismic energy quickly. The East Coast's crust is like a solid brass bell. When you strike it, the vibration travels. It rings. That is why the 1886 quake was felt from Boston to Cuba. The energy didn't dissipate. It propagated for thousands of miles through that cold, hard, ancient crust. The invisible fault, the ringing bell effect, a city built on liquefiable sand. The elements of a perfect disaster had been waiting in silence for centuries. Suddenly, the impossible quake of 1886 had an explanation, a source, an accomplice in the bedrock. And the scientists who found it also discovered something else. It was not a one-time event. The sand and water that erupted from the ground in 1886 left a permanent geological fingerprint. Those craters, known as sand blows, can be found and dated. By digging trenches and analyzing soil layers, paleoseismologists like Dr. Stephen Jaume at the College of Charleston have been able to map the region's deeper history. They uncovered evidence of other prehistoric sandblow events, other massive ground liquefying earthquakes. A pattern began to emerge from the ancient soil. Charleston, it turns out, experiences a major seismic event on a terrifyingly regular cycle. Roughly every 500 to 1,000 years, the hidden faults beneath the city accumulate enough stress to rupture in a massive quake. The 1886 disaster was not a freak occurrence. It was simply the last time the clock struck midnight. 140 years have passed since that night. We are now living inside the next cycle. The stress is building again, inch by inch, year by year. And the city that sits directly on top of this geological time bomb is exponentially larger, more complex, and more fragile than it was in 1886. The uncomfortable question that the science forces into the open is not if the big one will happen again. It is what happens when it does. The answer is in a report. In 2001, the South Carolina Emergency Management Division, SEMD, conducted a comprehensive risk study using federal Jesus modeling software. They asked a simple question: what would a direct repeat of the 1886 earthquake, a magnitude 7.3, do to the Tri-County area of Charleston, Dorchester, and Berkeley today? The agency reaffirmed those findings in early 2026. The answer is not a disaster. It is a societal collapse. 900 fatalities. That is the baseline estimate. 15 times the death toll of 1886. More than 44,000 injuries, a number that would overwhelm every medical facility in the state simultaneously. The economic losses would top $20 billion in South Carolina alone, a figure that eclipses the damage from the most powerful hurricanes. But the numbers do not capture the reality of the aftermath. The true horror lies in the cascading failures. The Jesus study predicts more than 250 fires would ignite at the same time across the Charleston metro area as gas lines sever and electrical grids short out. And the infrastructure to fight those fires would be gone. The report estimates that 80% of urban households would lose running water. Not for hours, not for days, for weeks or even months, as a spiderweb of underground pipes, many of them old and brittle, shatter under the strain of soil liquefaction. Imagine a city burning with no water to stop it. The unreinforced brick and masonry that give historic Charleston its singular charm would become its greatest killer. Those beautiful, centuries-old buildings were not constructed with seismic resilience in mind. They were built on the assumption the ground would stay still. In an M7.3 event, they will fail catastrophically. Schools, hospitals, fire stations, bridges. The SIM study specifically identifies these ordinary structures as points of catastrophic failure. They were not built to flex. They were built to stand, and they will fall. It's a vision of a modern American city plunged into a pre-industrial nightmare in the space of 90 seconds. A city on fire, without water, with its hospitals collapsed and its bridges impassable. That is not an estimate. It is a simulation. A blueprint for a future that the geology beneath Charleston has already promised will arrive. The only question has always been when. And now, the ground is starting to move. The recent earthquake swarms are not an abstraction. They are a physical reality for the people living in the Midlands of South Carolina. Since December of 2021, a relentless series of tremors, mostly small, has been centered around the towns of Elgin and Lugoff in Kershaw County. By April 2024, this single swarm had generated 97 distinct earthquakes. Dr. Stephen Jom described it bluntly. We've had more than our fair share in the past few years. The activity has been so unusual, so persistent, that it has drawn a massive scientific response. Institutions like Georgia Tech and the USGs have deployed temporary grids of nodal seismometers across the Elgin area, blanketing the region with sensors to create a high-resolution, three-dimensional map of the fault structures below. They are trying to understand an anomaly. These quakes are not originating from the Woodstock-Ashley River fault system. They are happening on a completely different network of faults, known as the Eastern Piedmont Fault System, over 100 miles away. The director of the South Carolina Seismic Network at US, Dr. Dan Frost, along with network manager Dr. Philip Crotwell, are now managing a state with two distinct active seismic zones. One of the leading theories for the Elgin swarm is itself unsettling. Scientists like Skinner's Scott Howard are investigating a possible link between the earthquakes and fluctuating water levels in the nearby watery river. The hypothesis is that as the river level rises and falls, the changing weight of the water alters the pore pressure in the rock deep below. This slight change in pressure might be just enough to unstick a fault that is already critically stressed. It is a phenomenon known as hydroseismicity, and while it's been observed near man-made reservoirs, seeing it potentially triggered by a natural river on the East Coast is profoundly unusual. It suggests a system so close to the breaking point that even the subtle weight of a river can push it over the edge. So, if the Elgin swarm is a separate issue, a fire alarm going off in a different part of the house, does that mean Charleston is safe? Or is it the opposite? The tectonic stress pushing the North American plate westward is a single, unified force. The pressure isn't isolated, it's distributed across the entire continental crust. If that stress is now great enough to trigger a swarm of nearly 100 quakes in the Midlands on a fault system thought to be quiet, what is that same level of stress doing to the much larger, more dangerous Middleton Place-Summerville Seismic Zone? The fault that has already proven it can produce a magnitude 7.3 quake. Is the Elgin swarm a release valve, bleeding off pressure from the system? Or is it a symptom of a much larger problem, a sign that the entire crust of the region has been pressurized to a new, more dangerous state of instability? No one knows for sure. The swarm is a live, ongoing experiment, and the data is still being collected. But it has shattered a century of complacency. That complacency is written into the skyline of Charleston itself. Unlike in California, where seismic codes are a fundamental part of life, much of the East Coast has built as if 1886 never happened. The vast majority of older structures have not been retrofitted. Newer buildings may follow modern codes, but there's a pervasive sense that lightning won't strike twice. The memory of the disaster has faded, becoming a historical curiosity rather than an active and present danger. People worry about hurricanes because they can see them coming on a satellite. The threat from the ground is invisible. It operates on a timescale too long for human memory and too deep for human sight. The city's greatest asset, its beautifully preserved history, is also its greatest vulnerability. Imagine walking down Rainbow Row or the Battery, surrounded by architecture that has survived for centuries. In a major quake, those unreinforced masonry walls become projectiles. The historic ironwork twists and shears. The foundations, sitting on liquefiable soil, fail. This is the central, brutal paradox of Charleston's future. To protect the city from the next earthquake would require fundamentally altering the very character that makes it unique. Retrofitting is expensive, intrusive, and often seen as unnecessary until it is too late. So decisions are deferred. Budgets are allocated to more immediate problems, and the pressure under the ground continues to build, indifferent to zoning laws or budget meetings. The current swarms have, for the first time in generations, forced the issue back into the light. The work of scientists at the South Carolina Seismic Network has never been more critical. Every small tremor recorded in Elgin is a data point. Every measurement from a GPS station is a clue. They are listening to the earth, trying to interpret the whispers that come before the roar. But seismology is not a predictive science. It can identify risk, but it cannot provide a date. It can map a fault, but it cannot say when it will slip. So Charleston waits. The city is a museum piece sitting on a time bomb, protected from the sea by a barrier wall, but completely exposed to the forces stirring beneath it. The tourists come, the population grows, and the economy thrives, all on land that has proven it can come apart without warning. The 2026 report from CIMD is not a fantasy. It is a plan for a funeral, a pre-written obituary for a city that has not yet died. It details how many shelters will be needed, how many casualties to expect, how many square miles will be rendered uninhabitable. It is the cost of living on a fault line that you have chosen to forget. The awakening in South Carolina is real. The ground is talking. It is telling a story of accumulating stress and surprising instability. The quakes at Lake Murray and Cross Anchor are not the main event. They are the prelude. They are a reminder that the forces that shattered Charleston in 1886 did not vanish. They are still there, waiting. The question is no longer about geology. The science is settled. The risk is known. The catastrophic potential is mapped out in excruciating detail. The question is now about choice. Does this unprecedented swarm, 100 miles away, finally break through a century of inertia? Does the rattling of homes in Elgin serve as a wake-up call for the far greater danger lingering beneath Charleston? Or is it just another strange, forgettable headline, dismissed as a curiosity, while the real clock, the 500-year cycle ticking under the coast, moves 1 second closer to its inevitable conclusion? The warning has been issued. What happens next is not written in the rock. It is written in the